Good morning and hello to everyone present in this brief presentation of PragmaDev Studio version 5.5.3. So this will be a brief presentation and demo of the new features we introduce in this version. My name is Mihal Brumbuli. So I will start with a very short introduction of the technologies used in our toolset. So we provide modeling and testing tools because we believe that modeling helps developers, architects to concentrate on what rather than how, in order to ease communication, improve legibility, get control over productivity in order to improve the quality, and of course greatly reduce the development time. We believe that for a modeling language should be based on some very important principles. For that, we offer several modeling, the modeling and testing language used in our toolset. Both of them are event-driven, that allow a system-level description for communicating systems, for example, and this is the specification and description language. We believe that it is very important for those languages to be complete and self-sufficient, so that there are no ambiguities in order to have fully executable models. So the specification and description language at the modeling level or the modeling part of the toolset, and the TTCN3 testing language for the testing part. Both of them are formal languages, meaning that they include an action language and very clear execution semantics. So our goal is to offer a very complete, self-sufficient languages in order to allow the models and the tests to be executable. So PragmaDev Studio is a set of tools that includes 4 different tools, starting with PragmaDev Specifier, PragmaDev Developer, Tester, and PragmaDev Tracer. So every one of these tools is included in PragmaDev Studio, but they can be also used separately. PragmaDev Specifier is based on the specification and description language, and allows execution of SDL models, also with the provided simulator. PragmaDev Developer, on the other hand, is based on the SDL-RT modeling language, which takes the graphical representation of SDL, but instead of using the action language provided by SDL, instead it introduces C and C++ action language. The PragmaDev Tester is based on the TTCN3 testing language, and from PragmaDev Tracer you can generate code and executable to test either a model, for example, in SDL, or real systems that are deployed on different platforms. The PragmaDev Tracer is actually a tool which is integrated in all other tools, and of course in PragmaDev Studio, and is based on message sequence charts. In addition, PragmaDev Studio provides also different other functionalities in addition to the above mentioned tools like Specifier, Developer, and Tester. Mainly these include, for example, a performance analyzer, a deployment simulator, etc. So to start, what is the important part of this presentation? Here is a list of the new features, or the most important ones, introduced in the new version of PragmaDev Studio, that is the version 5.3. These main features include a generation of tables in OpenOffice and not only documents, starting from PragmaDev Studio, support of requirements table in Reqtify, an improved built-in library, PragmaLib, a type declaration and statement wizard for SDL, a new widget for building graphical user interfaces, which interface with an SDL model. And the main feature of this new version is the support of a simulation of cyber-physical systems via the functional mockup interface version 2. So I will briefly describe some of these features in a couple of slides. Then I will do a very short demo of some of the features. So first of all, the generation of tables. Starting with this version of PragmaDev Studio, tables containing documents in PragmaDev Studio can be exported either in OpenOffice, Word, or HTML. Another feature is support of requirements table in Reqtify. So PragmaDev Studio could import requirement files in CSV format and keep links between the textual requirements, the model, and the test. Now, PragmaDev Studio already had an integration with Reqtify traceability tool. So tracing information in the model could be read by Reqtify. Starting with the PragmaDev Studio version 5.3, Reqtify integration goes one step further and makes the link between a PragmaDev requirements table and the Reqtify tool. Another feature is an improved built-in library PragmaLib. PragmaLib was introduced in a prior version of PragmaDev Studio that allowed users to manipulate files and create graphs in both the modeling language and the testing language, that is in SDL and in TTCM3. Starting with this new version of the tool, it is possible also to write formatted data to strings in order, for example, to pass those strings or to pass those strings to the functions that write to files, for example, or create graphs. So these functions, this list of new functions, is based on the sprintf c-like function. That is, for now, it supports writing of formatted data of Boolean types, real types, integer types, and of course, character string types. The use of PragmaLib is as simple as use PragmaLib in an SDL specification or importing everything from this module in TTCM3. So that's it for a brief introduction of some of the features, and now for the remaining features and the most important ones, the support of the functional mockup interface, I will do a short demo of all of these features. So first, let me open a project, and as a start, I will show the completion wizard feature that is from this version of PragmaDev Studio, as it is not always easy to remember how to declare a new type, for example, in SDL. A new declaration wizard is introduced. So this wizard is available, for example, in declaration. So I will put an SDL declaration symbol, and if I right click there and try to insert a new declaration, I have a list of choices. So if I select, for example, a new sync type declaration, you can see that a given template is automatically filled, and there I can change, for example, the type name, the base type name, the default values, and the constants that belong to the new sync type declaration. So this makes it very easy for now to declare, for example, complex types in SDL. So I will remove this declaration. I will open a process that is a finite state machine in SDL. And the second part of this help to the user consists in introducing a wizard for different statements. For example, it can be, so the procedure basically it's the same. If I introduce a task block, then I can right click and insert a new statement. For example, if I click a for loop statement, it will be filled the task block with the template of the for statement in SDL. So which makes it even easier to insert, for example, complex behavior into task blocks. So that's it for this feature. The next feature is the introduction of a new widget in the Graphical for building graphical user interfaces in PragmaDev Studio. And this widget is a gauge that includes values from 0 to 100. So this can facilitate, for example, expression of values, for example, percentage values that may come from the outside or the environment. There was actually a reason for introducing this new widget in the GUI part of the tool. So we needed a representation for the speed and the throttle of a car, because from this version of PragmaDev Studio includes support for the functional mockup interface that allows simulation of cyber-physical systems in PragmaDev Studio. So, and for that we had an example of cruise control FMU. So the FMU is a functional mockup unit that starting from this version, it is possible to import such units in PragmaDev Studio and co-simulate them with an SDL model. So let me close for now this diagram, so I will not save any changes. So in principle, the functional mockup interface allows to combine, for example, event-driven and clock-based elements, or critical parts and non-critical parts, in order to construct very complex models. So it allows to bring together in a simulation environment, for example, physical models, synchronous models, and via PragmaDev Studio also asynchronous models based on SDL, or event-driven models based on SDL. So I will shortly show in this demo a cruise control example. So for this example, this is actually the SDL part, which includes a single block called cruise control, and this is the interface to the environment. So basically, the block cruise control accepts cruise speed, throttle command, and cruise state coming from the environment. These are the messages actually that will come from the functional mockup unit that I will show you how we can import such unit in PragmaDev Studio afterwards. And going out from the cruise control block to the environment are the messages listed here. So you can imagine now an extended, we can call it extended architecture for the moment, that we have the cruise control block modeled in SDL, and outside or connected to this channel, it's an FMU or a functional mockup unit that in this example is a cruise control FMU provided by Skate, by the Skate tool. So on the other hand, here we have another channel connected to the cruise control that it is called GUI, meaning that this channel will serve as a connection to the external interface that I showed a little bit before of a cockpit of a car with a set of buttons and the new widget in order to show the speed, for example, the throttle, and be able to send brake, acceleration, and turn on and off the cruise control. This example that I'm going to show right now is also included in PragmaDev Studio with a new version in the list of examples. So if I go inside the cruise control block, this block has a single process encapsulating the behavior in this case. And if I go inside the block, show you that it has a very simple state machine, so which basically handles with a simple behavior all the inputs coming from the graphical user interface and also the inputs coming from the external functional mockup unit. So here I can navigate all the transitions. Because the functional mockup unit actually needs a speed in order to do its thing, the calculation of the speed is done in SDL, but it's a very simple model just to provide some values of speed for the unit. So one of the important parts, as I mentioned before, is the import of a functional mockup unit. So if I go to the generation options for this model and to the FMI2 tab, provide a new interface in these options, I have several fields that I have to fill in order to correctly import or load an FMU. So first of all, I will activate the use of FMI2. The second step is to load an external FMU. In this case will be the cruise control. So here I have a log of what's happened during the loading of the FMU, because the FMU has several levels of logging, and also this gives a very detailed feedback if something went wrong during the load of the external FMU. So I will close this window, and here we can see that both of the tables here have been filled. This information is actually what's inside the FMU that I loaded. So these two tables consist in the FMU parameters, and the FMU parameters are actually variables that for now they cannot be changed during simulation or during execution. These may be these act as a constants during simulation. The second part, or the second table, consists in FMU inputs and outputs. What it means is that having the channel in the architecture of my SDL system, I had a channel connected to the environment. And as I mentioned before, this channel connects the block cruise control in SDL with the FMU. So in this table, I will now do the actual mapping of the messages or possible messages for each of the inputs and outputs of the FMU. So here I can see what type the FMU variables present in the actual FMU that I've loaded before are. So the acceleration, for example, here is a type input. So what I will do, I will map this one with the same message in SDL. So in here, the list of messages is in order to help the user in choosing the messages, there is a filter of the messages. So only those messages that can be mapped to this input acceleration are shown. So I will continue with the mapping. So for the brake, it's the same thing. So I will map the cruise speed to the message. The cruise state also, and continue with the other inputs and outputs for the given FMU. So quick acceleration, resume, set the speed, and the throttle command. The parameter I will not change, but of course it is also possible to change the parameters. Now, the second important part of the whole this process is to decide, first of all, the step size at which the simulation will be carried, and this is needed in order to actually execute the SDL system together with the FMU. In this case, this information is provided here by this parameter that is actually 0.1 seconds. So as a time unit, I will choose milliseconds here, and I will put 100. The log level is messages shown during execution by the FMU, so that one I will make leave it to info. And the FMU kind. Now, the FMU kind can be either model exchange or co-simulation. And this is to say that PragmaDev Studio supports both these modes, that is model exchange and co-simulation of FMI 2.0. The simulator of PragmaDev Studio acts as a master if the chosen FMU kind is in co-simulation mode, or acts as an importing tool if the chosen FMU is in model exchange. So in this case, I will choose model exchange, and I will apply the changes to my generation options. So now what is left to do is to execute my system. So I have here the PragmaDev simulator. The next step, what I will be do next, is open the graphical user interface that I showed in the editor before. So I have here the cockpit of the car. So nothing happens for the moment. I will run my system, and here in the log window we can see that the execution goes on, but nothing happens in the interface. So what I will be doing next is to accelerate, for example, with 80. And as I push accelerate, we can see that the throttle goes to 80% and the speed starts rising. So what I will be doing next is activate the cruise control and set the acceleration to 0. So now we have a green LED here, meaning that the cruise control is in on state and the speed that it is trying to maintain is 82.4. And we can see here that the throttle command moves in its own, meaning that it is controlled actually by the FMU. So what I can do, for example, is try to decrease the speed that the cruise control should maintain, as I did, and we can see that the throttle moves always up and down, and it will try to regulate and maintain the desired speed. Another thing I can do is, for example, brake. I have it in red right now, the cruise control. I can disable the brake and then resume the cruise control. And as you see, the throttle is controlled by the FMU and will try to regulate the speed with towards the desired value. Also, if I try to accelerate, we can see the change in the color, meaning that now it is in standby, the cruise control. So if I push 0 for the acceleration, then it's green, that meaning it's on, and we'll try to reset the desired speed. In this case, it will be 67.4. I will stop the simulation for now and close everything. So basically, these are the new features in the new version of PragmaDev Studio. So please, if you have any questions, you can write in the chat part, or you can drop us an email so we can answer you afterwards. So thank you for participating in this short presentation of the new features of PragmaDev Studio version 5.3.